Hello and welcome to my channel. This is the first film about a Matlab environment. This is a introduction to a larger course which will be about numerical computations and computer simulation using Matlab and Python. The Python will be presented in separated videos, and the entire course intends to cover the typical university program, so it will be quite large. Okay, but today first basic informations about how to use Matlab and what you need to know to start with programming your first numerical computations. Okay, so what you can see here is a typical Matlab layout. Here we have a folder tree, here we have the description window. When I choose some file and the file have a description, so the description will be here. Okay, those descriptions aren't in English, but it's not important for now. Okay, so this is a command line. The command line is used during the work in Matlab mostly for purposes of control. If you want to check what is in some variables which are in workspace. Workspace is here. Then you can write it in a command line and check. You can also call here some functions you prepared, and this is main idea of using the command line. Most of the work in Matlab is about writing your programs, which is done in a script editor, which is this one. Okay, I just opened it. But first we need to talk a bit about how Matlab view the variables, how he performed the certain mathematical operations. So for this reason I will use command line. Okay, so Matlab takes his names from matrix laboratory, and this means that each particular variable, even a single number, is in Matlab considered as a matrix. What does it mean? For example, if I create a variable a and write there a single number, just like 1, okay, in my workspace it occurs the a is a matrix. It's considered as a matrix, 1 by 1. Okay. Why it is important? Because also in a default mode Matlab use every mathematical operations such as the matrix vector operations. What does that mean for us? It will be clear in a second. Okay, but first let's create some real matrix, for example 2 by 2. Okay, so when I do not create any variable and just start to create a matrix like this, what will happen? Okay, I press enter, and now you can see two things. Firstly, that my matrix was created in that way that I input first row, separate the elements of the columns by the comma, and then separate rows by the semicolon. This is the way how we create matrices in Matlab, and we also need to use square brackets, which is here. Okay, and the second thing is that because I do not create any variable, that it was created automatically, and the variable name is ans. And if I now create some other I put some other command, for example just press 1, enter, that the variable ans is overwritten. That means that my previous matrix is lost. Okay, so this is important to have in mind for later, but now let's go back to our matrix. Okay, to do what I've just done, I used the arrow up. Okay, so for now let's create the vector b. Let's get the name to this matrix, for example a. Okay, and then create a vector b By vector I mean the vertical one. In case of mathematical notation, the vector should be a vertical, and the something like this should be called as a single row matrix. Okay. Why it is? It is because of the algebraic interpretation of vector and of matrices, but I will make a separate video about it, or I can also put a link to a great video on another channel in the description. Okay, so let's make the vector b like this. Okay, so now we have matrix A and the vector b, and as I said, as a default, the mathematical operations are conducted in a matrix vector mode. What does that mean? That means if I put this expression, I will obtain the result of matrix vector multiplication, that matrix with this vector. Okay, and it is in accordance with our expectations. Okay, nice. So now I will clear those variables, and I use the command clear. Okay, I clear also the command line using the clc command. Okay, and now I will create two vectors. Okay, the one is should be called the single row array. Okay, this is the horizontal vector, and the other will be vertical. Okay. I've done it to show you that vector multiplication can be done in like this. Okay, and now we obtain a single value in accordance with the rules of matrix multiplication. Okay, on the other hand, if I perform this multiplication in that way, the result will also be in accordance with matrix vector multiplication rules, and this is such an array. I know that some of you may find this quite annoying, but you know, if you have in mind all of these rules, that will save you a lot of time later on when you start to write your own programs later in this course, for example. Okay, so the other type of multiplication in Matlab is elementwise multiplication. What does that mean? That means that if we have those two vectors, okay, A and B, and we want to multiply first element with the first element, second with second, and third with third, we can do it in like this. Okay, so I've used the dot here to have my element-wise multiplication. Okay, but here, because one of the vectors is horizontal and the other is vertical, I've obtained such an result that each element of the second vector is multiplied by first, and this is the first column, then by second, and this is the second column, and so on. Okay, if I want to have, for example, a single horizontal vector which will have the elements which are the results of multiplication of the corresponding elements of vector A and B, I need to have the vector A and B in the same form. What I mean is that I need vector A and vector B be both horizontal or vertical. And to obtain it, for example, I can transpose vector B. So I write B, okay, B, this is the transposition mark. And what the transposition is just like this. So the column becomes a row. Okay. And now when I have it, I can do the multiplication. in like this, and I have the row vector in this form. Okay, if I would like to have the resulting vector in the form of the vertical vector, what I can do? I need to have my A vector in a form of vertical vector, and also the B vector in a form of vertical vector, which I transpose to obtain it. Okay, and now I can perform same multiplication. Okay, and I have my results, but in the form of vertical vector. Okay, those things are very important to have in mind, because it really save your time, because when you will start with Matlab, you will really often face an error, which is that matrix dimensions must agree, and the causes of this error is just because you can forget about those rules, and times to times you may want to perform the multiplication or assignment, which is incorrect in case of the matrix dimensions. And if it happens, just need to go to the workspace and check, are those dimensions in a matrix of your variables, your matrices, are in accordance with your expectations. But probably there will be some errors in a beginner's stage of your learning. Okay, so then another topic, I mean the referring to the elements of matrix. So how the matrices are addressed. Okay, so let me create some matrix, maybe call it A. Okay, let that matrix be a bit bigger, because it will be better for us. Okay, maybe one more. Okay, and now, for example, if I want to get some elements from the matrix and assign it to a variable, so I create the variable and get the element. To get the element from matrix A, I need to first refer to this matrix, so I call A. And now I would like, for example, to take this element. This is element of second row and second column, so maybe we'll take this because it's element of second row and third column. The indexing in Matlab starts from 1, not like in Python, where it starts from 0, but about Python we will talk in separate video. Okay, so when I would like to take this element, I address it by 2 and 3. Okay, and now you can see that the variable s contains 7. Nice. Okay, if I would like to assign to the s not only this number but entire column, so how to do it? I need to set that I need all the rows, which I'm doing by colon operator, and then the number of column, which is 3. Okay, nice. And for example, if I want to have in my variable s all of these elements, mean all columns and the second row, I just change this a little bit in this manner. Okay, so first I need to refer to the row, so it's the second row, and all columns. Okay, and this is it. Nice. If I would like, for example, to take only those elements, for example, from the second to the third, okay, how I can do it? The row is a second row, so there is a 2. Okay, from the second to the third. Okay, I use operator column to tell Matlab that I want columns from this to this, so from the second to the third. Okay, and if I would like from the second to the fourth, of course I change this to the 4, and this is the result. Okay, of course same idea is when I wanted to have, for example, those two elements, 2 and 6. So how to address it? Okay, I need to address the rows first to the second, and this is second column. Okay, in like this. Okay, so this is quite simple. Okay, if I would like to have, for example, from the second row, from the second element to the last element, I can use AND. And this is, as you can see, from the second to the last. Okay. This is just to improve clarity. Okay, so we still have this matrix. Nice. So now we know how to get elements from matrix. So now I would like to show you how to change the elements in the matrix. So for example, I would like to change this element for 12. Okay, so it is quite similar, but first my matrix, which now will be the place where I assign my new value, should be on the left side of the operator equal. Okay, so A, now the address, and I would like this number, so it's second row and the third column. Okay, and I would like to give the value 20. Okay, so now I have my matrix with a 20 here. Okay, and this is similar to what we learned before, because if I would like to, for example, change the values of those two elements, I can do it in like this, using the colon operator. Okay, and now I can make some vector which needs to have same dimensions as those to the assignment be possible. Okay, and as you can see, the assignment is okay because here we have our new values. Nice. What if I would like to, for example, delete the column from matrix? This is quite simple. For example, I would like to delete the last column. So every row, all rows, and last. So I will use the AND, and now I will use the empty square brackets. What do we have? We have our matrix without the last column. Okay, so more or less this is all about addressing the elements in a matrix. Okay, so now we can move a bit further. Some lacks of information will be later in the course, because it will be better for you to have those informations when they will be needed during the course, not all of them now. Okay, so now we will open the script editor and start our first program. Okay, first of all I clear the workspace and the command line. Okay, now here I can create a description for my file. The description I'm creating here will be later in this window when I choose my file from the cut folder. Okay, So okay, there will be a space to have our description area. Okay, some descriptions, not important now. Okay, those comments are often on the top of our script file. Why? Because before we start our program, we need to clear the workspace to avoid some mistakes which can be caused by the variables same name which can be in the workspace. So before starting our program, we firstly clear the workspace. We also clear the command line. Why? Just to have a clear look if we check something in this line. Okay, and times I also use this expression, which is about the format of the digits which are displayed in the command line. The short format is for most time okay, and things not becoming too messy even if it can be in a long format. I'm sorry, English is not my native. Okay, so let's create our first little simulation program. What I intend to show you now is the representation of the domain in case of numerical computation is always discrete. And it is really important if it comes to some mathematical stuff which we're dealing with, for example derivatives and other things. Later in the course we will talk a lot about the order of approximation, order of other methods, for example to solving differential equations and so on and so forth. All of this is caused by the representation of domain in numerical computation. The domain is always represent discrete, and now we will see what I mean by it. For example, we have the domain of our function from 0 to 10. So how I can create such domain in Matlab? I do it in like this. So I creating the variable, okay, okay, this is the variable. I also use the semicolon here. Why? Earlier I didn't use it because I want my variables to be shown in a command line to let you see them, but now I don't want it, and this is why semicolon is here. Okay, so when I start this, you can see that x is such a long vector. This is a horizontal vector, I will call it like this, which contains 1001 element. Okay, so my domain is represented in like this by the finite set of points which are placed between 0 and 10. Okay, and now let us make a plot of sine function. So to make this plot I need to compute the values of a sine of x. Okay, how to do it? I can do it in like this. Okay, nice. So now you can see that there is another vector y, which is also in the form of such finite set of values. Okay, so what is important in case of numerical computation? First, in a really basic point of view, our domain is represented in a discrete form. So our function is, what is our function? This is a set of the approximations of the true value of the function which are obtained for the points which represents the domain, and the points which represents the domain are in x, and our approximations of the values of sine are here in y. Okay. So now to make a plot, we just do it like this. Okay. What I have done here, I've used the two inbuilt function, two embedded function of Matlab. First function is sine. This is a procedure which allow us to compute the values of sine of x. Okay. And I also use the plot function, which is a function which can make the plots. Just very simple. Okay. So now we have the plot. Okay, we have the plot. Nice. But what if we would like to another thing. For example, if I do it in like this, would it work or not? Yes, it would. I will show you. Okay, so what can we notice here? We can notice very important thing, because the Matlab as well as other programming languages have this feature that the functions are called from inside to outside. What I mean? I mean that first the sine function were called and the approximations of the sine has been calculated for the points collected in x, and then the plot function has been called to make our plot. Okay, and this is the effect. Okay, and this is quite important information about how the programming languages works, that the functions can be called from inside to outside. Okay, but what if we would like to have quite more sophisticated function than just sine? For example, we would like to define our function. Okay, so how we can do it? In like this. Firstly, we need to some name for our function. Okay, then we need to tell Matlab that it will be a function. Okay, we use the add operator for it. Now we need a name for our input. I will use u for it. Okay, and now we need the function, so the body of our function, and for example it can be 2 times input plus sine input. Okay, so we have the function, and now we need to calculate the value of this expression for these points. And we still use this feature that functions are called from inside to outside, so I can do it in like this. Okay, and now first those values will be computed and then the plot will be updated. Okay, and we have some other function. Okay, nice. I would like to show you another thing which is quite important to have in mind, and for this reason I make a change which intentionally cause an error, and we will analyze this error. Okay, so I change the here to multiplication, and my intention is that that each element of the input u, which is a vector, because remember that u is in the case x, and x is a vector. Okay, so each element of u will be multiplied by 2, and then each element of this vector will be multiplied with corresponding element of this vector, because this also will be a vector. U is a vector, so this will be a vector of the values of sine of u. Okay, But would it be work in like this or not? Let us check. No, it will not. Why? Because as I said, this is vector and this also is a vector. And I would like to have the element-wise multiplication. So each element of this will be multiplied with corresponding element of this. And to obtain it, I need to use this operator of element-wise multiplication, which is, as you can see here, suggested by Matlab itself. Okay, and first I would like to show you how the Matlab let us know about the error. So the error occurred in this line. This is not you may think that here, because here is my real mistake, here I made my mistake, but the error occurred in the program here. Why? Because here this function is called, and Matlab reported in that way that here on the last position on the bottom there is where the error occurred, in which file, in my case is untitled 2, okay, line 11, this is line 11, okay, and then Matlab reported also where is the mistake. This mistake is in the definition of this expression and it is here, okay, and on the top there is a suggestion from Matlab how to fix this error. In this case of really simple error, the suggestion is correct, and most of time it is, but not always, which you will also see earlier. Okay, so we make this element-wise multiplication, and as you can see, now we've got proper result. Okay, in this video that's all, but in the later videos I will show you how to use while loop, for loop, ifs, and other stuff in Matlab, and later we will start our first numerical computation topics. I will also prepare similar videos in case of using Python to later use also Python in our numerical computation course. Okay, so if you enjoy it, please give a subscribe and see you soon.